Our topic is identification of ions, and these ions include positive ions and negative ions both. You know, a salt consists of both the positive and negative ions. So here you can see that it is our objective to describe the use of aqueous sodium hydroxide and aqueous ammonia to identify the following aqueous cations. These include aluminium ion, calcium ion, zinc ion, ammonium ion, iron ion, iron 2 ion, iron 3 ion, copper 2 ion, and chromium 3 ions. Aluminium to ammonium, these are the ions which usually gives colorless transparent solution. And iron to chromium, these are the ions which usually give colored solution. So when you are going to identify cations and anions in the given sample, then you first notice whether the solution is colorless or colored. So solution might be colorless transparent. If solution is colorless and transparent, then what are the chances? Then we have the chances that cations might be there: ammonium ion, aluminium ion, calcium 2 plus ion, and zinc 2 plus ion. If we have colored transparent solution, then we might have copper 2 ion, iron 3 ions, iron 2 ions, and chromium 3 ions. There might be some other ions, but in our syllabus of Cambridge, these are included. Now, this is the strategy then how to identify cations present in the colorless transparent solution. We take a small quantity of that solution in a test tube, then we add sodium hydroxide dropwise. On adding this, we might have two types of results. We may get white PPT. If we get white PPT, then there are the chances of aluminium, calcium, and zinc. If we don't get white PPT, it means there is the chance of ammonium ion. And definitely further tests are required. If we get white PPT, it means there are chances of aluminium, calcium, and zinc ions. So you can see here. Then we further proceed our detection technique. Then we add in the same test tube excess of sodium hydroxide. Means where we have added a few drops of sodium hydroxide, now we are adding in excess. So again, we have two types of result. PPT remain insoluble, or PPT may be soluble in excess of sodium hydroxide. If they remain insoluble, it means there are the chances of calcium ions. And if PPT are soluble in excess of sodium hydroxide, then we have the chances of aluminium and zinc ions there. But further tests are required. Further chemical analysis is required for final identification of these ions. So it is the first step. We usually use only these two alkalis, that is sodium hydroxide and ammonium hydroxide, for detection of these ions. And you will see it further. Now, we have to distinguish between aluminium and zinc. Then what we do, we again take a small quantity of solution, our sample solution, whatever they given to you. Then we add ammonium hydroxide dropwise. A little quantity dropwise is added to the air. Then we get white PPT. And these white PPT might be of both either aluminium or zinc hydroxide. Then we add this ammonium hydroxide in excess. In excess of ammonium hydroxide, there are two possibilities. Either this either these white precipitates which we obtain on adding ammonium hydroxide dropwise may dissolve in excess. If they are dissolved in excess, it means zinc ions are present in the solution. On the other case, if these PPT remain insoluble in excess, it means aluminium ions are present there. Suppose you have a sample, unknown sample. We don't know whether it is aluminium, ammonium, zinc, calcium, but it is obvious that it is colorless solution. You can see in the diagram, it is a colorless solution. So the colorless transparent solution means in our syllabus, only 4 cations might be present. That is ammonium, aluminium, zinc2 ions and aluminium ion. So what we do, as we have described in our scheme, we add sodium hydroxide dropwise. So there are two chances: either we get white PPT or we get no PPT. So here we obtain white PPT. If white PPT obtained, then we have already learned in our previous slide, then there are the chances of aluminium, calcium and zinc ions. If PPT were not present, if we did not get these precipitates, then it means we monitor the odor of ammonia for detecting the presence of ammonium ion. Anyway, we will see it later on. Right now we have got white precipitate, so we will add excess of sodium hydroxide here. On adding excess of sodium hydroxide, what is the result? You can see here, it becomes transparent. Here it has white precipitate and now it is transparent, and it is if it is transparent, it means the PPT that we obtain in the first step are dissolved in excess. If PPT are dissolved in excess of sodium hydroxide, then there are two chances, either aluminium or zinc. If white PPT were insoluble, then there would be the possibility of calcium ion, but it is not the case here. Now, with the same sample A, we will distinguish between aluminium and zinc ion. So we add ammonium hydroxide in a small quantity dropwise. Then again, we obtain the white precipitate. White precipitate means there are the chances of aluminium and zinc ion. And then we further add ammonium hydroxide in excess. And you should note that ammonium hydroxide aqueous is also known as liquor ammonia. Same name is given for this because it is dissolved by it is obtained by dissolving ammonia gas into the water. So again, what we got white PPT are soluble in excess because it has become transparent. What is the inference? So it means zinc is present. So in previous slide, we tested this sample with sodium hydroxide, and then we finally concluded that it is either aluminium or zinc. So here we have a distinguishing test between aluminium and zinc ion by ammonium hydroxide, and we finally concluded that sample A contain zinc ion. If these precipitate would not dissolve and they remain as it is, then it means these would be aluminium ion. We will see in later slide. See, now we have sample B. Sample B is again colorless and transparent. So here you can see on adding sodium hydroxide dropwise, we get white precipitate, and this white precipitate means there might be aluminium, calcium or zinc ion. We are doing the same procedure for another colorless transparent solution. So steps are similar. You can see here all possibilities are similar. If we do not get the precipitate, then we will monitor the odor of ammonia for detecting ammonium ion. But here we have got white precipitate, so we will proceed further, and in excess of sodium hydroxide we can see that it is soluble. That's why there are chances of only aluminium and zinc, no chance of calcium, because if white precipitate remain insoluble in excess of sodium hydroxide, then there would be the chances of calcium ion. Now, again, the distinguishing test between aluminium and zinc, as we have performed previously for sample A. So you can see we have a colorless solution of sample B that we have tested in previous slide, and we have reached up to the result that there might be aluminium ion or zinc ion. So here you can see again we have got white precipitate while we are adding a small quantity of ammonium hydroxide. It means there might be aluminium or zinc because we have already performed some experiment in previous slide. In excess of ammonium hydroxide, here the result is different as compared to the sample A. In sample A, on adding excess of ammonium hydroxide, we got the transparent solution here, but here the solution remains, the precipitate remains insoluble. So if precipitate remain insoluble, it means this solution contain aluminium ion. So up to this, we have identified two ions, zinc ions and aluminium ion. Now see the sample C. In sample C, it is also a colorless solution. You can see that on adding sodium hydroxide in a small quantity, again we have got white precipitate, and these white precipitate shows the presence of aluminium, calcium, and zinc ion. Again, remember that we have a fresh sample C, so we cannot exclude the possibility of calcium. Okay, so there might be the white precipitate of aluminium, calcium, or zinc hydroxide. And again, if PPT does not form, it means we should monitor the odor of ammonia after warming a small quantity of this reagent. So on adding excess of sodium hydroxide, what we get here, we are getting no change because there were precipitate on adding small quantity, and again we are having precipitate even we have added excess of sodium hydroxide. If precipitates are insoluble in sodium hydroxide, if these white precipitates are insoluble in sodium hydroxide, it shows the presence of calcium ion. So white PPT remain insoluble in excess, so it means calcium ions may be there. Why maybe? Because there might be some impurities. So we will further confirm our result in this slide, in the next slide, by using ammonium hydroxide. And here notice the similar as we have seen in previous slide. Sample C, again for the confirmatory test for calcium ion. You can see here a colorless solution on adding ammonium hydroxide dropwise. We have got no precipitate. Ammonium hydroxide in a small quantity gives no precipitate with calcium. If there is calcium, and we have shown our probability of calcium ions present in sample C, so our result is compatible with our previous result with sodium hydroxide. So no PPT formed. So inference is that there might be calcium. Still, it is not confirmed. Then we will add excess of ammonium hydroxide. On adding ammonium hydroxide in excess, usually we do not get any precipitate, but sometime due to the change in concentration or disturbance in concentration of our reagent, we may get slight white precipitate sometimes. So in both the cases, inference is same that calcium is present. Now, we have already seen in our initial slides that if we are testing our aqueous solution, that is aqueous transparent colorless solution, on adding sodium hydroxide dropwise, and we are getting no PPT, it means aluminium, calcium, and zinc may be absent. May be absent. So what may be present? So ammonium may be present. Now, for the possibility of ammonium, for monitoring the presence of ammonium, what we do on the same test tube where we have added a small quantity of sodium hydroxide dropwise, we warm it on Bunsen burner. Then on warming, we may feel ammonical smell. It is a peculiar smell of ammonia gas that we can see and you can experience when you are in the laboratory. So what is the inference? Inference is that there might be ammonium ion. Then we proceed further. Further testing is required. See in the next slide. Again, we have the same solution. We will add sodium hydroxide dropwise, then warm. Ammonical smell can be felt as we have seen in previous slide. But this, this result that you observe by using your natural receptors in your nostrils, it is not reliable. So we perform some chemical tests. What are these two chemical tests? In first test, on the same test where we have add small quantity of sodium hydroxide and added the and we have put it on the gentle flame. So near the mouth of the test tube, we bring a glass rod dipped in HCl. So what may happen? It may give white fumes. If white fumes produce, it shows the presence of ammonium. Or on the other hand, you perform the same test that you add a small quantity of sodium hydroxide in your given sample solution, then warm it, and now you bring near the mouth of the test tube a red moist litmus paper near the mouth of the test tube. What would happen? You may see the change in color of the litmus. Red litmus turns blue. If you are using blue, blue remains blue. And in your syllabus, only ammonia gas is alkaline in nature that can convert red litmus into blue. So both of these results, we perform both the test, and both of these results show the presence of ammonium ion. In our next slide, this is the practical demonstration in the form of diagrams. So you can see here we have a sample solution in the test tube and we are adding aqueous sodium hydroxide. Then in the next diagram, see what we are doing. We are warming it. So warming the contents of the test tube, that is sodium hydroxide in our sample solution. In the next, you can see the change in color of the litmus. They have brought red litmus paper near the test tube, near the mouth of the test tube, where we have already performed this test, that is the adding sodium hydroxide then warming. So on bringing moist red litmus paper near the mouth of the test tube, you can see the result in the next diagram that this litmus turns blue. So if the moist red litmus turns blue, it shows the presence of ammonium ion in the given sample. Now, another confirmation test is HCl, concentrated hydrochloric acid. We will perform the same test, adding a small quantity of sodium hydroxide, then we warm it. Then after warming, now we are doing something different. This is the glass rod. We have dipped it in concentrated HCl, and then we brought it near the test tube, near the mouth of the test tube. So you can see the result in the next diagram. See here, what is the result? We have obtained white fumes here, dense white fumes obtained due to the formation of ammonium chloride. And we have already seen such results in acid-base chemistry. So white fumes of ammonium chloride are formed. So these results are showing the presence of ammonium ion in the given sample.